This lesson is on radian and degree measure. The essential question for this lesson is, how do you describe angles using both radian and degree measure? An angle is what we're going to start with, and an angle is determined by rotating a ray, which is a half line if you might think of that, a starting point and no ending point, rotating this ray about its end point. The starting position of the ray is the initial side, as you can see in the diagram, and the position after rotation is the terminal side, okay? So the ray starts at the initial side and rotates, in this case, in a counterclockwise direction to the terminal side. This is considered to be a positive angle, and the endpoint is referred to as the vertex of the angle. Now, normally, the perception of an angle is that it fits in the coordinate system where the origin is the vertex and the initial side coincides with the positive x-axis. Such an angle is considered to be in standard position. Counterclockwise rotation generates positive angles, and clockwise rotation generates negative angles. Now, if we have an angle, two angles that have the same initial and terminal sides, they are considered to be coterminal. Now, if we look at our diagram here, we have one angle starting from the initial side going to the terminal side in a counterclockwise direction. Similarly, if I have an angle starting from the initial side and going to the terminal side in a clockwise direction, we have two angles with the same initial side and the same terminal side, so they are considered to be coterminal angles. So now let's discuss measuring the angle. We can measure an angle by the amount of rotation from the initial side to the terminal side. And one way to do this is to measure the angle in radians. So let's start by considering the central angle of a circle, whose vertex is the center of the circle, as shown in the picture here. In this case, 1 radian is the measure of a central angle theta that intercepts an arc S equal in length to the radius r of the circle, as we can see in the figure here. Or algebraically, we could say that theta is equal to S over R. So you can see that theta is equal to 1 when S is equal to R, in this case, 1 radian. Now, if we use the fact that the circumference of a circle is equal to 2 pi r, so therefore C is equal to 2 pi r, and we talk about the entire circle, one complete revolution, the angle theta, if it's one complete revolution, will equal the circumference of the circle, which is 2 pi r, divided by r, or in radians, one full revolution of the circle will equal 2 pi radians. So one complete revolution is equal to 2 pi radians. Now, since we know that one complete revolution in degrees is equal to 360 degrees, we can get a conversion here in that 360 degrees is equivalent to 2 pi radians. Now, using this fact that 360 degrees is equal to 2 pi radians, we can come up with a conversion. To convert degrees to radians, we simply multiply the degrees by pi over 180. Or if we want to convert radians to degrees, we multiply the radians by 180 over pi. So degrees to radians, multiply by pi over 180. Radians to degrees, multiply by 180 over pi. So let's look at one last formula on this page, and that is, how do we calculate the arc length? Well, as you recall, arc length is simply equal to S, okay? And if we look at our formula here, that our angle is equal to arc length divided by r, we can get the fact that arc length will simply be equal to the angle in radians times the radius. So arc length is equal to the angle in radians times the radius. The last thing that we will consider is the area of a sector of a circle. Now, another way of looking at this is you could think of this as being the area of a slice of pizza, okay? We know how to do the area of a full circle. Its area is equal to pi r squared. But let's say we have a sector or a slice of pizza of that circle. What is the formula then? So let's assume we've got a circle and we have a sector, and basically we want to determine the area of this whole piece here, this slice of pizza, if you will, okay? So we know that angle is theta. We know the radius is r, okay? So the area in this case of that sector is simply equal to 1/2 r squared theta. So it's 1/2 the radius squared times the angle theta. Now, remember, the angle theta must be in radians to use these formulas. It must be in radians. You cannot do this in degrees. So theta must be in radians, okay?